Okay, now as a last application, we look at something called finding average value of a function. Now the average of finitely many numbers is very easy. You add them up and then you divide by how many there are. For example, average of 1, 3, and 5 is 1 plus 3 plus 5 over 2. 9 over 2 is 4.5. But what if you want to average over infinitely many values? So basically, what does that even mean? For example, average temperature. Now this is what the temperature looks like for a place, and I want to find the average from time A to time B. Now what you have here is all of these, there are infinitely many values, and you cannot potentially add all of them. So what we do is, we do our standard calculus trick, we divide it into n time steps, right? Assume that during that time step it's almost constant, and the smallest change is delta x equals b minus a over n. Then the average is just the sum of the function values over those endpoints divided by n. But what is n? N is b minus a over delta x, which when you substitute, you end up with this equation, and under the limit, that becomes the integral divided by b minus a. And that's called the average value. For example, find the average value of f of x on this interval. So you go 1 plus x squared dx from -1 to 2, 1 over b minus a. And that's 1/3, and you have x from -1 to 2 plus 1/3 x cubed from -1 to 2. And that's 1/3, 2 minus -1 is 3, plus 1/3, 8 plus 1, that's 1/3, 3 plus 3, which is 2. A mean value theorem for integral. If f is a continuous function on AB, then there exists a number c in AB such that, what this means is c is greater than equal to a and less than equal to b, then f of c equals the f of the average equals 1 over b minus a integral ab f of x. In other words, this integration equals fc times f of b minus a, where c is between a and b. This is a pretty useful relationship. That's it for this week's video.